only 30% were reproducible. So people were able to get the same results by following the same protocols that they had. So that's a big problem. So
only 30% of, and these are studies published in well-known, like well-respected journals. 30% are reproducible studies.
Yeah.
So 70%.
That they were not able to get the same results as the study when they did the same thing as them.
So 70% of studies, according to this study, this meta-analysis, whatever it was, according to this, 70% of reputable studies from their sample size, you can't repeat the results that they got.
Like,
so in terms of science, they're not reliable.
I mean, I'm having a tough moment with science, to be honest, right now. I mean, I've been having a tough moment for the past few years, also finishing my Ph.D. And I'm sure any person that goes through getting a PhD will have that same feeling where it's like you're really kind of like, I feel like a priest, you know, like second guessing my faith. I kind of feel a bit like that with science. And so to actually get into the meat of the subject with different aspects of academia that I'm frustrated with. So because of this publish or perish thing, there's a lot of added stress, and added stress tends to lead to either mistakes or deliberate mistakes. So
when you say stress, do you mean the stress of the job performing the task, or do you mean it's stress on top of the normal anxieties?
So publications mean you getting a job, you not losing your job, you getting grants. And scientists need grants to have a job and do research.
Okay, so it's extra stress on top of just performing day to day.
Yes.
It's like existential stress of, will I publish enough to stay around?
It means if you don't publish enough or regularly enough, you will perish, as in your career will perish. So there's like this big pressure to publish, and to publish in like good journals. So journals that are considered reputable by the scientific community. And you know that because they have an index that let you know like their quota. So like 40 is really high. That's journals like Nature, Science, Cell. And then most of them are more like around the 10. And 10 is still like a really good journal. And then you have like where it starts getting low is around 2 or 3. And below that, it's like we don't trust it. So these indexes, so where you publish is important because people will judge your work based on where you've been accepted as in a journal. So you want to publish a lot in good journals. And another big problem is most journals, like over 90% of those journals, do not accept negative data. So negative data means that your result doesn't align with the hypothesis that you've set out. So in a way, like it didn't work. However, in science, it not working could just mean that this is not the right solution. So one way I like to look at it is like you have an idea, you have a question, you have a research questions, and there's like 10 doors in front of you. So what you're going to do is like, you're going to try to open the first door. Is this answering my questions like expect? No. Then I'm closing it and I'm trying the next door. However, if after 5 doors, I'm like, it hasn't worked and I'm out of funding, so I can no longer go with my project, I cannot publish that none of these 5 doors worked. I can only publish that door 6 worked. And so people might try those same 5 doors again and again because there is no indication that someone may have tried and it was just not the right answer. And what this means, it means that you've got this one hand, you have pressure to maybe bias your data to tell the story that is positive so that you can still publish a paper and not lose your job, lose your career and all this. It means that people might lose money, use more animal lives for questions that have already been answered, just not in the way that we would want them. So it's like a big problem in like figuring out whether the result that have been published is true, and that's participating in the fact that a lot of those studies are not reproducible. I think there was this other study that showed that only 30% of all studies done that they had assessed, and there were like 1,000 different studies, only 30% were reproducible. So people were able to get the same results by following the same protocols that they had. So that's a big problem. So
only 30%?
Yeah.
and these are studies published in well-known, like well-respected journals, 30% are reproducible studies.
Yeah.
So 70%.
That they were not able to get the same results as the study when they did the same thing as them.
So 70% of studies, according to this study, this meta-analysis, whatever it was, according to this, 70% of reputable studies from their sample size, you can't repeat the results that they got.
Like,
so in terms of science, they're not reliable.
Yeah, that's essentially, like, I can't remember what the percentage was.
That seems absurd. That's like
it does.
That's like enough to stop science and be like, hey, can all the scientists get together? Can we have a meeting and talk about how this system is not working? Way more times it's going wrong than it's going right. 70% of the time. That's crazy. That's like
so now that's the thing is, like, certain labs are better at avoiding this as possible, and this is why, like, you need to increase your sample size. You need to just redo the same thing many, many times, and so journals also getting stricter with that. So people are working hard towards avoiding and making studies more reproducible and more trustworthy, but it's just difficult because at the same time, by having these additional constraints, it becomes a lot more work to get to publish. And then you have competition with other labs and you don't want to get scooped. So having someone publishing what you're researching before you, because then you lose potentially years of work because someone else already published what you were going to publish. So there's just like always different pressures. And this is why it's kind of like feels like a race where you need to like work really hard, publish as fast as possible, the best thing possible, and then move on to the next thing or work in parallel. So it makes the job really stressful. And I think one really easy solution would be to just publish negative results. Just allow people to publish when they did this thing and it did not work, so that at least you can be like, hey, I have this idea. Let's see if someone else has already done it. Did it work? And oh, look, that person did almost exactly what I was thinking of doing and it didn't work. But maybe I'll try it slightly differently. But at least I know that this very thing has been done, and people wouldn't be as pressured because they could be like just doing science and reporting when it's working and when it's not.
Yeah. And at the very least, there should be some sort of public database where if you do have negative results, you can post them. You can post what it's about so people can search and say, hey, did someone do this already? Because if you're in a lab and someone else in a competitive lab against you maybe is doing an experiment that gave you negative results in the past, and because of the current system, you'd be incentivized to go, oh, like, I never tried that. Maybe you should keep going down that road. And in the back of your mind, this person's going to waste the next 4 years of their life, but I'm going to get ahead. Exactly.
Plus, you could be like, if it doesn't work, you have the contacts of the scientist. And then you can like start a scientific discussion being like, oh, did you try this? Like, did you analyze your data this way? And then it could be like, oh, actually, I didn't think about that. Like, it's just like, there's such a great way to start scientific conversations and discussions, and just like by sharing what doesn't work. And you have so many brilliant people that can like look at it with you and maybe be like, oh, maybe you should try this, or I'll try this differently.
Yeah, it just seems like the current system is broken, with 70% of things not being reproducible, and this is from very reputable journals. I think it should be more in line with what happened over COVID, where you sort of, and again, I still believe that there should be some sort of a review process and a mechanism to filter out the bullshit papers.
Absolutely.
I don't know if peer review is that process. It seems like it can become very political. It's, there can be biases in there. Selecting a certain number of people to look over a paper and them deciding whether to pass you or not. Like I've even heard, I forget if it was you told me this or maybe I was listening on a podcast, that like there are some cases where a peer reviewer can like essentially guess who's writing the paper based on where it's coming from, what the topic is. And they could be like, I hate this person. Like, I'm just going to, give them a bunch of bullshit corrections that they'll never be able to fix.
I mean, that's why you also have several reviewers, and like the editor sees it too. They see the comments, and if the comments are just ridiculous, they can judge that too, So like, thankfully you do have multiple people, and in certain journals it goes as far up as like sometimes they send it to 5 different people.
Yeah.
And you have the editor that also like knows the topic.
But from what I understand with COVID, because it was such an immediate need to get to understand the virus, to get vaccines, to get treatments, we essentially said, okay, we're going to put a halt or lessen the peer review process, and we're going to open source the entire thing. So labs across the world, we're not competing to get published in a journal to take credit for the vaccine or take credit for the treatment, understanding the virus and its novelty. They were just all sending things open source and sharing and saying, hey, we found this 2 days ago, lab from Italy. And then another lab in Korea is like, oh, we found the same thing. Like, here's this. And then someone else is like, okay, this is all the things we tried. So, you know, you don't have to waste your time doing this, or we found this out. And then another lab goes, okay, we could stop. They figured it out. Now let's work on something else. I think we need categories like that where we have something like COVID, and then maybe we have like malaria, and then maybe we have like cancer, and everything is open source, and we still give people credit. We still give labs, you know, the recognition, but there's not this like, we're going to sort of sneakily compete to get a limited number of spots in one of like the 4 top journals that can only publish a certain number of things a year, and your incentives are different. You're studying things that you believe will actually make a difference rather than the things that will be most likely to get published. Because another thing that I just wanted to touch on with what you said is if you're not if you can't get negative data published, if you study something and it ends up being the opposite of your hypothesis, you're going to be highly incentivized to go after the safer things that you believe will give positive results.
Right.
And you're not going to go after, you know, the monsters in the closet if you don't believe that
they're like real groundbreaking science.
Yeah. You're not. You're, if you believe you're going to perish, you're going to go after the easier things.
Absolutely. And I mean, so to come back to one of the first points that you've just made, even if so. And I think one problem is maybe with the open source and the public. So I think we need to fight misinformation. And the best way to fight misinformation is by educating people on how to critically read anything that they read and question it. And so I can't speak for every scientist, but I know that I've been trained to read journals critically and question everything I read. And so, yes, which journal is being published in, and the fact that it's been published in a good journal that's peer reviewed does give me the idea that it's like, it's mostly okay. Or maybe I know this lab and I know it's a good lab, but ultimately I need to question, you know, like, is their sample size big enough to make this conclusion? And so I think at the very least, if we had this database, it should be methods and results. I think where it gets dangerous is the discussion, especially when it's non-scientists reading it and what the interpretation the researchers make of their data. And sometimes and that's why I think it's good, because the peer reviewers tend to like bring them down to the ground, being like, you can't extrapolate your conclusion to other illnesses or just make that conclusion. And this is why I think a lot of the papers are also very, what's the word? Like they're softened, you know, they're not like, this makes this. It's like, we believe
more cautious language.
Yeah, it's more cautious. And I think actually that's my hypothesis as well. But one of the reasons maybe climate change has not been considered seriously for so long is because scientists also have been taught to use cautious language versus maybe politicians and stuff that are not afraid to say bullshit, or journalists. And so if you tell people it looks like there's a correlation between ice melting and human activities, people are like, well, he didn't say that we did it. He said that maybe perhaps there is a correlation.